Hello coders, welcome back to my video. So you wrote socket, then bind, and then we have the listen system call. So what is this listen system call used for? Why we use bind in this socket server programming before the listen system call? And what is a backlog actually means? What happens inside the kernel when you use this listen system call? And what actually is done within the kernel. These all things we'll discuss in this session. So let's start with a basic introduction of listen. So listen marks a socket as passive socket. So what it means is it will not connect outwards. It will wait for the incoming clients to access using this TCP server. Okay, so this is the form of a TCP server, program, and your client will connect to this listen system call. Okay, so why it is needed? So after the socket, you only create a socket object. After the bind, you attach the IP and port, and now we have the listen system call with the kernel accept connection request. So connection requests are coming from the external programs, and this will actually work as a listening socket. Okay, so it will not send any connection out of the server, but it is only listening to the incoming connections from the client. Okay, so I think this is clear. So it will generate a queue inside the kernel which will handle all the socket connections. Okay, so these all the communication is basically done within the kernel side. So here, how we call this API. So we have the file descriptor. So this file descriptor we already get from the socket system call, and bind take it to map IP the port number. Now we are using the listen operation on this same file descriptor. Okay, so we are using this file descriptor. Along with that, I am using this backlog. So most of the newcomers thought like this backlog is the number of connection it can accept. For example, we have 5 connections that only this server can accept, but it's not true. It's actually the backend queue that will handle the simultaneous connections. So for example, we get 5 connections at a time, and this TCP listening socket can accept one at a time. So it will only accept the 5 connection out of, for example, 10 connection we have. Okay, and all the 5 other connection they will reject. Okay, so there will be a timeout on that client sockets because there is no room to accept that sockets at that particular time. Okay, so what is the limit of this backlog? So, for example, I wrote 5. If I wrote 0, what it have? It is very minimal thing, like only one connection it can take at a time. When that connection is processed, then it take the next connection. All other connection which are coming simultaneously that will be rejected. Simple as that. Okay. So, what is the upper limit? If we put 1,000 or 2,000 on this backlog, will it work? So it depends on the kernel, this file. So this all operation is dependent on this max connections that this server can accept. If you put a value more than this, so it will not accept that connection. So the limit we can see from here. Okay, so let's actually jump directly to the man page of this listen and see what it says. So here you will see listen for connection on a client. Okay, so we have these header files that we need to include in our program for our listen system called uses. So listen marks the socket referred to a socket FT as a passive socket. That is, as a socket will be used accept an incoming connection request using accept. So accept we'll see in the next session. So the point here is it just listening? It is not accepting the connection as it is, right? So for accepting the connection, they need a accept system call. So this only holds a queue in the kernel that some connection might be coming, but still our program don't have the capability to process that connection and establish a TCP three-way handshake. Okay, so for that they need a accept system call. Okay, I think this is clear. So here it is mentioned the backlog argument define the maximum length to which the queue of pending connection for socket FD may grow. So if a connection request arrived when the queue is full, the client may receive an error with a indication of connection refused. If it is underlying protocol retransmission is happening on the client side, it will again try to connect, but that is a different case from the client side. So on success, we have zero uh, as return value, and on error, we have -1 along with an arrow values set. So these are the arrow values which we have. So let's go back, quickly jump into the kernel space deep drive APIs which we have. So I am taking this V7.0 kernel version, that is a recent one right now, and this is the flow. For example, we have a listen system call here, and we have a glibc wrapper that is being called after that. Then we have a system call entries, and it will directly go to this API that is in socket.c. Okay, then it calls system listen in the same file socket.c in net. Okay, then it will search for the socket fd which is already created, and will get the environment. Then it will map your listen, and these are the last APIs that is being called uh, in the kernel side to put that socket fd in the listening state. So first is the inet listen. So if we quickly go to this API, so let's search here for inet listen. So its definition is there in net IPv4 AF underscore inet, and it is version 7.0.1. So if I quickly go here and I get this values, okay, so inet listen sk is being called, and its definition is in the same file. Okay, and if we go here, so here we have this inet csk listen start. So this socket whatever is been provided, that is been turned up into a listening socket, it is accepting the connection. So if you want to dive into this kernel code where it happens, so you can go to this link and find out. So I listed few of the APIs that is commonly be traced. Okay, so here we can get the this listening state of that socket. Okay, so let's take a example. So here we have a simple socket programming, and here we have a socket system call already discussed. I created a TCP socket here, and after that I am filling this socket in with IP and port number 8080, and I am binding that to the socket, and then I am putting in the listening state, the same socket here. And now our server will start in the waiting state, and we have a sleep somewhere here. And if I compile it, gcc hyphen o, I have listen. Okay, then I have listen api.c. Okay, so now I got the listen. I run in background. So the process is 3054 now. If I use netstat hyphen NALP and I grep for my process ID 3054, and you will see here your socket now is being shown in the netstat. Okay, with the IP and the port been mapped to that socket and it's in the listening state. Socket is in the listen state, but still is not useful until we use the accept. So we will see how to use the accept in the next session. So this is all about the listening socket. See you in the next video. Thanks.